Bismillahirrahmanirrahim. My name is Ehtasham Raza, rule number 9859. Today the topic of discussion is fuel cell. A fuel cell is an electrochemical device that converts energy produced from a chemical reaction into electrical energy. More specifically, it is an electrochemical device that combines hydrogen and oxygen to produce electricity with water and heat as its byproduct. Now we moves on to its construction. First part of construction is anode. Negative post of the fuel cell conducts the electrons that are freed from the hydrogen molecules so that they can be used in an external circuit. Etched channels disperse hydrogen gas over the surface of catalyst. Second one is cathode. Positive post of the fuel cell edged channels distribute oxygen to the surface of the catalyst, conducts electrons back from the external circuit to the catalyst, recombine with the hydrogen ions and oxygen to form water. Third one is electrolyte. Proton exchange membrane. Specially treated material only conducts positively charged ions. Membrane block electrons. Fourth one is catalyst. Special material that facilitates reaction of oxygen and hydrogen, usually platinum powder, very thinly coated onto the carbon paper or cloth. Rough and porous, maximize surface area exposed to hydrogen or oxygen. The platinum coated side of the catalyst faces the PEM. Now we moves on to its working. A fuel cell generates electrical power by continuously converting the chemical energy of a fuel into electrical energy by way of an electrochemical reaction. The fuel cell itself has no moving parts, making it a quiet and reliable source of power. Fuel cell typically utilize hydrogen as the fuel and oxygen, usually from the air, as the oxidant in the electrochemical reaction. The reaction results in electricity, byproduct water and byproduct heat. When hydrogen gas is introduced into the system, the catalyst surface of the membrane splits hydrogen gas molecules into the protons and electrons. The protons passes through the membrane to react with oxygen in the air and forming water. The electrons, which cannot pass through the membrane, must travel around it, thus creating the source of DC electricity. Now we moves on to types of fuel cell. First one is alkaline fuel cell, second one phosphoric acid fuel cell, molten carbonate fuel cell, solid oxide fuel cell, proton exchange membrane fuel cell. First type is alkaline fuel cell. This type of fuel cell was being introduced in early 1960s. It has compressed hydrogen and oxygen fuel, potassium hydroxide electrolyte, and its efficiency is 70%, and it's operate on 150 to 200 degree temperature. Second one is molten phosphoric acid fuel cell. Is the electrolyte used in this type of fuel cell. It operates at high temperature up to 200 degrees Celsius. It has an efficiency of 55%, and 11 MW units have been tested. Platinum catalyst is very expensive. The electrolyte is very corrosive. Third one is molten alkaline carbonate, which is made up of bicarbonate, and it is used an electrolyte. They can produce high powers up to 100 megawatts. Thus, they can be used as high power generators. They can also be operated at high temperature up to 650 degrees Celsius. They are not so expensive in production and hence can be used for commercial uses. It has an efficiency of almost 55%. This is one of, and five number is proton exchange membrane fuel cell. This is one of the most commercial used fuel cell as they have the highest operating life. It has a very high operating temperature of 1000 degrees Celsius, but other parts of the fuel cell may not be able to withstand at this temperature, making it highly unstable. As the device has a very high operating temperature, there are some disadvantages as well. There may be unwanted number of reactions taking place inside the cell due to the high temperature. As a result of these reactions, carbon dust and also graphite may be built up on the anode, making it insufficient for reacting with the catalyst. The last one we explain is solid oxide fuel cell. It was mistakenly explained, but now we explain proton exchange membrane fuel cell. Proton polymer electrolyte membrane fuel cell, also called proton exchange membrane fuel cell, deliver high power density and offer the advantages of low weight and volume compared with other fuel cell. PEM fuel cell use a solid polymer as an electrolyte and porous carbon electrodes containing a platinum or platinum alloy catalyst. They need only hydrogen oxygen from there and water to operate. They are typically fueled with pure hydrogen sulfide from storage tanks or reforms. PEM fuel cell operates at relatively low temperatures around 80 degrees centigrade. Low temperature operation allows them to start quickly and result in less wear on system components, resulting in better durability. However, it requires that a noble metal catalyst, typically platinum, be used to separate the hydrogen electrons and protons. This is the presentation, and Allah Hafiz.